All right, hello. Once again, thank you for joining us. My name is Aaron Gunnarsson with Passive House, Massachusetts. Really excited to welcome everybody for today's workshop. We have some excellent speakers lined up. So it's not just myself talking today. You get some excellent experts. I'm giving you a lot of info today as well. We're going to get started here in a couple minutes. I just want to introduce myself and introduce the other speakers here in a moment, but want to let you all know to use the chat room feature to write any questions that you have, any comments. We'll address them throughout the presentation today. And then afterwards, after everyone is done speaking, we'll actually open it up to group discussion. So we can answer some questions from the chat room there. We can even unmute you at that point if you'd like to answer some or ask some questions directly. During the session, keep yourself on mute. You can feel free to share your video screen if you like. I'll leave that up to you, but it is nice to say hello. Hope you all can see me out there and hear me just fine. But again, use the comment room or the chat room to say any comments, anything that you like. But this is Passive House. It's a session designed for builders and for contractors and in trades. We're going to cover some very basic sort of Passive House principles and get into some examples of detailing and stuff you might see on the site. And then we're going to get into some case studies and some lessons learned from some folks. But to everyone out there, thank you again for being here. I'm going to give one more plug to the chat room to say anything you want in there as we go through the session. So I want to thank MassSave, who is helping to put on this session today. They have a Passive House training program that's been running for a couple of years. Passive House Massachusetts has been working with them on this to put together a whole host of different content. So thank MassSave for putting this together, and the sponsors of MassSave listed on the bottom. One of the great benefits of this program is that they're giving us reimbursements for certification trainings. So this includes the Passive House Builders training and the Passive House Trade Person training. So if anyone's interested in taking those, who hasn't already done so, you can get 50% off the registration costs through MassSave. And if you've actually taken it any time during the last couple of years since this program started, you can still get reimbursed. So if you've taken it a couple of years ago, going back to when this program first started, you can still submit for that reimbursement. So it's 50% off. And this includes the online courses they're offering now. In the COVID era, they shifted both the builder's training and the trade person training are offered online. Some are offered live. They also do have some on-demand sessions as well that you can sort of do online, sort of when it fits your schedule. So really easy to do. So that's through MassSave. You can also direct questions to Passive House Massachusetts about that. But here's the MassSave training info there. But thank you to them, and please take advantage of that rebate if you haven't already. So here's what we're covering today, though. We're going to talk about, well, welcome. That's me doing this right now. But then we're going to get into some Passive House principles. I'll be kind of leading that and talking for a few moments about some principles behind Passive House. Then we'll get into some case studies and lessons learned. So we have Nat Coughlin here from LD Russo. He's there, and we have Ed Sopel. I don't see him on video screen yet, but he'll be here from Delbrook JKS. So they'll both be sharing some case studies of projects and lessons learned from their experience and answering questions from you guys. And then at the end, we'll get into some group discussion with everybody. But thank you all again for being here, and we're going to launch into some Passive House principles. As I go through this, if you have questions or things you want me to talk a little bit more about, use the chat room to use that. The first thing I want to highlight is just when we talk about Passive House, we're talking about all different types of buildings. The phrase Passive House comes from the history of Passive House starting in Germany way back when, but the truth is passive buildings. So we have single family homes, large multifamily buildings, large towers like the one you see on the bottom there, office spaces, university residence halls, all types of buildings can be Passive House. So just because of the term house, don't let that fool you. Everything can be a passive house. Even an old existing building can be retrofitted into a passive house. So this is a row house in Brooklyn that was retrofitted to become a passive house. So let me do this here. Now you can see with the thermal image, this is what a passive house looks like, right? We put the big blanket around the home, trap all the heat in. Very basic summary, but that's what we want a passive house to look like, at least in winter, right? Sorry, I'm going back and forth and admitting people here at the same time, so only slightly distracted. So what does Passive House achieve? We're getting a dramatic reduction in overall energy use. This is the main thing you hear us talking about all the time, and it tends to be the main focus of Passive House is reducing energy demand. But the reality is we get a lot of other benefits because of that. The main one being a reduction in carbon emissions. We also see a proven improvement in air quality, health, occupant comfort, greater ability, durability. and resilience to major weather events. So you might have a building that can, say, stay warm in the winter for a longer period if electricity goes out, or right now or the last several days, if anybody had their electricity go out and their AC stopped working, their home could stay cool for a lot longer than a traditional home could. So those are some of the meanings behind resilience to major weather events, but some of the things are becoming a lot more important about a passive house building. We, of course, see lower operating costs because of lower utility bills, and we get a pathway to net zero. So passive house are not necessarily net zero by definition, but they provide a great platform for buildings to become net zero by reducing energy demand so significantly. The certification for a passive house building is built on a couple concepts, but the main ones are around performance criteria. So we're not going to get into any of that today, but I just wanted to let you make sure we are all on the same page of at least what a passive house is measuring. And that is heating and cooling demand, so the amount of energy it takes to heat or cool the space, whole building air tightness, so this is measured through a blower door test, and then source energy demand, which is basically a way of saying the overall energy use of the building. So passive house has criteria for each of these metrics. So the focus is on reducing space heating and space cooling demand, but there's also a metric for overall energy use. So you do have to look at ways to address everything from water heating to plug loads to reduce that overall demand. Then there's other criteria beyond this that are sometimes called soft criteria, but these things address everything from ventilation rates to sort of the way you're managing moisture and humidity, and then there's also different quality assurance measures as well that goes into it. So there's these sort of soft criteria that are built into it, but the main ones we sort of focus on are the energy metrics. How do we achieve this? And kind of the things we're going to be talking about today are a lot of these principles that go in these design features of passive house buildings. So these are sort of the main ones, the very broad topics, but it sort of gives you an idea of what we're talking about. So continuous thermal insulation. So that means, within the cavities, filling those, dense packing those with insulation, but then also wrapping the building in continuous layers of insulation. Having thermal bridge-free construction, or at the very least, reducing the impact of thermal bridging. Airtight envelope, so having an airtight layer around the building as well. Then using high performance windows and doors, having optimized solar heat gain, so designing the building in a way that you can get some sunlight and heat energy into the building in the winter and try to keep it out in the summer. Balanced ventilation, so we keep the building really airtight, but then we have balanced ventilation systems to make sure we're delivering fresh air to the building. And then using efficient and minimized mechanical systems. So that's the ventilation system and also the heating and cooling systems for the buildings. So with very few exceptions, these buildings are not truly passive. They have mechanical systems. They do use heating and cooling, but we use efficient systems and we minimize the size of them and the amount of time we need to use them. So let's get into some of those principles here. So thermal insulation, this is giving you an example, but we're talking about that barrier around the building of continuous insulation and the dense packed cavities on the inside. So this building you're seeing a photo of is a passive house in Wayland. And the brown kind of layer you see going on the outside of the building is mineral wool fiber insulation. And they put multiple layers of this around the entire building. And this is one example of continuous insulation wrapping around the building. So this is something you might see on passive house projects. Here are some other examples. This is still the Wayland project, but some other photos of it. So on the top, you can see how they did the footings. And what they did here is use a double stud wall. So those footings are very, very wide because they did double studs, and that allowed them to fill that cavity with a lot of insulation, in this case, dense packed fiberglass. That's one of the ways, in this case, they got a really thick envelope and lots of insulation. They also, you can see, use a foam glass, which is sort of like recycled glass created into foam as the footings there. Here's a different example. This is a net zero building going on Belmont. Both these examples I'm showing you are from Auburndale Builders, a company in Newton. But here you can get an example of the wall they're using. So the R values here, the size of the wall, so you can kind of see. This is just a 2x6 wall, so not a double stud wall, just single with 2x6, though, dense packed with cellulose. And then on most of the building used polyiso insulation as the continuous layer. That's the sort of gray product or a silver product you see there, foil face polyiso insulation. Below grade, which hasn't been filled in yet, but they use some of the mineral fiber insulation there, and then they just push the dirt up against it. You can get an example of what they did on this project. And here you can see some of the typical R values we see in Massachusetts. Now, the passive house standard does not require any specific R value. The building code, of course, does, and you have to follow all those requirements. But in terms of passive house, it's not prescriptive. It's not saying you have to have this R value wall or use this type of material. Instead, it says these are the energy metrics you have to hit and do whatever you need to do to achieve that. But these are sort of the typical values we tend to see in passive house projects to give you an idea of what you're looking at. And here's an example of Finch, Cambridge, a multifamily building that just went up over the last couple of years in Cambridge. You can see what they used here for their project. So this is a photo of the dense packed cavities on the inside. And then this is the outside, where once again, they're using mineral wool fiber insulation, just like we saw at that Auburndale Builders project in Wayland. The big difference here is that they were able to use a lot less insulation. So they used one layer of that mineral wool fiber insulation on the outside, where that Wayland project used multiple layers. And this gets at one of the big principles around insulation, which is the larger the building, the less insulation you tend to need to use. This is specifically true of multifamily buildings, where you're going to have a lot of people and a lot of appliances and things producing heat on the inside of the building. You can tend to get away with less insulation on the outside than you would in a smaller building or a single family building. So that was thermal insulation. Now this is the other kind of big principle of that envelope with the talking about air tightness. So this is the Finch Cambridge project again, but this is what they use for air tightness. It's a air membrane from Sega, but it's all the blue stuff you see going up. And this was wrapped all around the sheathing of the building. And then they put the insulation, that mineral wool, on top of this. But you can see it going up. But you can see how critical that air tightness is in passive house projects, that they have signs like this one all over the building, making sure that everyone knew that this was an airtight building. You were not to mess with that airtight barrier. So this kind of gives an example of how critical that becomes on projects. Here's a couple more photos just to give you some other ideas. So the one there on the left is Elm Place in Vermont, a multifamily project there. In this case, they use zip system, which is something that's pretty common. You probably see it going up on a lot of projects, probably used it yourselves. But zip system is sheathing with an airtight layer built into it. So that's the green part of the sheathing there, is the airtight layer. In every case, what you see along with the airtight barrier material is tape. So in this case, it's the black product there, but they're taping all the seams, taping all the penetrations. It's very critical that those things are taped so you don't have those air gaps, and they're taped very well, that they're applied correctly. The one on the other side here is a single family home in Newton. This was by Group Design Build, a design build firm from Somerville. But they did it interior air barrier. So you'll see the air barrier on the outside, you'll see it on the inside. It varies from project to project. But in this case, it did the inside. Either way, the concepts are it's continuous. So it's wrapping around, that layer is going, everywhere around the project is wrapping, and it's being taped everywhere. So it's completely sealed. Give you a couple examples. That ceiling extends to where you have different fixtures and different things being installed. So in this case, windows or an electrical box down there on the side. This is Finch, Cambridge. Again, but you kind of see just how they're using tape and other materials to make sure that the airtight layer is continuing where all these things are being installed. This is the Wayland house now, so you can see it here, but exact same kind of concept. They use the Sega material, wrap the house, the mineral wool insulation went on top of it. And one last example, these are plumbing penetrations. This is Finch, Cambridge now, going back to that project, but you can kind of see how they went. So they, after the plumbing projects were first installed, they went through, they inspected them, they saw some that didn't work and had to be redone. Because the way that those things are installed, the way that they're sealed are critical. So something like that is not going to fly. So these are things that you have to think about on the job site and how you're working with the trades that are doing these different installations on the job site, because these things are important. Thermal bridges, another kind of concept I'll mention that in the wall envelope, but this is another thing that Passive House really focuses on, is reducing the impact of thermal bridges. Here you can kind of see just a single family wood stud home, but you can see how the heat's transferring through the wood studs. You can put all the insulation you want in between them, but you're always going to have heat transferring through the studs. So you want to reduce the impact of that. You can do that by having fewer studs, by, say, for example, doing 24 inches on center spacing rather than 12 or 16. You can also do, continuous insulation like we've been talking about. That reduces the impact on the other side of that stud by having some insulation. So there's things you can do to mitigate the impact of that. Here's on multifamily projects, some examples. So on the left, you see Finch. And this is how they attach that mineral wool insulation to the building. They use those red things you can see are little clips, and they're thermal bridge clips. That way you don't have metal fasteners going through the whole wall, connecting the insulation to the wall. Those little fasteners are thermal bridges. So in this case, they have little clips. And then on the right, you see Elm Place, that's a Vermont project. So they have a kind of steel framed podium construction. And then what you're seeing is kind of the vertical podium going up to where the floor would start. Kind of the framing for the floor. But what you see in those steel beams, it's kind of hard to make out on the photo, but there's a little kind of a gray disc that's a different color gray than the steel. And that's a thermal bridge. It's not completely reducing the heat transfer from the steel beams, but it's limiting, it's mitigating the heat transfer between those steel beams. Those are things that you do in a passive house project to reduce thermal bridging, is you put these little thermal breaks in places. Different windows that work in passive house buildings, usually double or triple paned. The frames should have insulation and thermal breaks, and the windows themselves should be installed properly, so you're eliminating air leaks. There's some other notes here that you can take a look at, but we're not going to cover too much of this today. I do want to talk a little bit about solar heat gain. So in passive house buildings, this is actually one of the sources of heat in the winter months. We want sunlight coming into those south-facing windows and generating some heat for the building. But in the summer months, we want to block that out so the buildings don't overheat. So you can see some examples of that here. On the left is the Auburndale Builder's office. Those solar panels are on an awning hanging out over the south side of the building, and that provides shading in the summer. So the sun is up high in the sky and it's not able to directly go in the windows. But in the winter, it goes straight in. On Finch, Cambridge, on the right, you can see kind of another example of shading. The side sort of facing towards us is the south side of the building. You can see those little awnings over the windows. If you look on the east side there that we can see as well, there are no awnings. So they, in the design process, figured out that they needed solar shading on the south side, but the east side, that wasn't as critical, so they didn't put it there. But these are elements that you're going to see incorporated in different ways in passive house buildings. With heating and cooling, I don't want to, and ventilation, which I have another slide, I don't want to spend too much time on. This is on air source heat pumps, which is very common in single family passive house buildings. And we also see them used in a lot of multifamily buildings along with VRF systems. So you can see some kind of examples of the compressors here, both on the side of a house, of a single family home, and then up on the roof of a multifamily building. With ventilation, pretty much always seeing some form of a heat recovery ventilator or energy recovery ventilator. These are incredible systems. If you're not familiar with them, they provide 100% continuous fresh air being delivered to the building, and they're exchanging heat with the outgoing air. So rather than mixing the air itself, it's just passing the incoming and outgoing air over a heat exchanger to transfer from the heat without mixing the air. It's also passing the incoming air through a filter, so you're getting not only fresh air from the outside, but filtered air as well. So helping to deliver a higher level of indoor air quality to the building. I'm going to go through just one small example of a project, in this case, Auburndale Builder's office in Newton, and then I'm going to hand it over to other speakers today. But this was a retrofit. It looked like this old building up here on the top, which was sort of an old warehouse space. And they converted that into being a passive house office. And half of that space is used as a studio for high performance design and construction that does a lot of classes. Some of you have actually been there in Newton. So it's great to see you on this session. But here's a little bit about sort of how they did that, some different things. So they did slab insulation. So they took out the old concrete slab and they completely redid it by putting insulation underneath. In this case, mineral wool fiber insulation. They use the same product on the walls. So you can see that going up here. This is the sort of the air barrier that they put on the floor. So this is, you have the thermal insulation, and then they put this air barrier, and then the concrete went on top of that. So you have thermal insulation, air barrier, and then you have your concrete slab. On the roof, they insulated it as well. In this case, they were able to use salvaged foam. So from other projects they were working on and other resources, they were able to accumulate some salvage foam material, and that's what they stack on the roof to create 12 inches of foam insulation. So all sorts of different ways to use insulation on products or on projects, but the important thing is that you're using it and that you're doing this here. So in this case, that's what they use. Let's see. So this is the air barrier going up on the inside. So we just saw, for example, that mineral wool fiber insulation that went up on the wall. They would then put this air barrier system on top of it. In this case, it's a SIGA project, which is very similar to that blue stuff we saw going on the outside, but this is for the interior air barrier. And here's some dense packed mineral wool. So they did the framing, dense packed mineral wool. So you can kind of see, it's getting hard to make out here, but you can see there's sort of a very light fabric that's going over the wood studs. It's kind of, it looks like a very thin mesh, and that's exactly what it is. And that's meant to hold the insulation in place. So they put up that fabric mesh, and then they blow in the insulation. That fabric mesh holds it in, but that allows you to get a really dense packed insulation. So you have no little gaps in those cavities at all. And this is what it looks like on the outside. So that's the example that I'm walking through and some of the things that I wanted to highlight about Passive House projects and sort of the different features you get with them. What I'm going to do is turn it over to our other speakers today, Nat and Ed, to kind of walk through some of their case studies and lessons learned, and then we'll get some questions and some discussion with all of you guys. So first I'm going to hand it off to Nat. I can see you there. How you doing?
I'm good. I'm good.
I'm going to stop my screen sharing. And allow you to do yours. And I do want to remind folks that if you have questions as we're going through this, feel free to use the chat room. Let us know what you're curious about, what you want more details on, or just what you want to comment on, and we'll address them as appropriate. So please, Nat, take it away.
Great. And Aaron, can you guys see what I'm sharing now?
Yep.
Page? Okay, great. It's nice to see everybody, or virtually see everybody. My name is Nat Coughlin. I'm with LD Russo Construction. We're based out of Harvard, Massachusetts, up on Route 2, and generally we work from Worcester up to the North Shore. And we came into Passive House largely through our involvement in affordable housing, which has started seeing a real shift towards interest in Passive House. And so I thought I'd take this chance to talk a little. We've completed one Passive House project, and we're about to break ground on a third. And so I thought I'd just try and touch on some of the lessons I learned about how to approach the Passive House process as a builder, and things that we learned about what to watch out for, how to educate ourselves, because we were new to this. We were not early adopters. We came at it just from that the marketplace was asking us to get more involved in this. And I think we've had to learn some things as our team has come on board. So on this slide, you can just see, and I'll talk a little more about it, but the top right is the Waring School in Beverly, Massachusetts, which we just completed over the last year. We believe, according to the architect at least, that may be the first Passive House school building that's been completed in Massachusetts. They're trying to verify that, but that is what we think. And then the bottom left is what we call the Hillside YWCA, which is an affordable housing unit project in Newburyport. So let me just jump forward here, talking a little bit about and some of the things I've been touching on, but we actually right now have 3 people who are FIAS certified. I decided to do it first as we were starting to estimate some projects. And then once we won our first FIAS project, we actually got 2 of our project managers certified. And it is a good process to bring people through that training, because it gets people, I think, in the mode of understanding what's a little bit different. It doesn't necessarily mean you walk out knowing how to do everything, but you do learn a lot in those trainings that I think is really helpful, and having more team members up to speed makes it a little easier. So I mentioned we've completed the Waring School, which was actually a PHI, Passive House Institute project. So it was certified through the European-based standard. And then the one we're doing in Newburyport, the Hillside project, is actually FIAS. As a builder, the distinction isn't really meaningful, because we essentially build the plans and specs that we are given. I think it matters more to the designers and the raters who really get into the intricacies of the distinctions. Both PHI and FIAS are going to require you to pass a blower door test. They're going to have similar equipment. It's just about the devil's in the details for the designers. In addition to the 2 that we've done, we've got actually 2 buildings that we're starting in Salem in a few weeks that are going to be 46 units, another 25 units in Lowell next year. And then we actually, in the long term, think we have 2 buildings with 96 total units, all going towards Passive House. And a lot of that's driven by the affordable housing, which happens to be our market that we do more work in. So I wanted to compare and contrast the experience a little bit because I think it can be insightful for people getting involved in this process. At the Waring School, we had an architect who had done a number of passive house projects up in Maine, residential and institutional, college buildings, more commercial buildings. They really had a formula worked out that they've done successfully on a lot of projects. They also had a really contemporary building design, which meant a lot of the details around the added insulation that Aaron was talking about and around the way you need to air seal the building. We weren't restricted by trying to meet conventional details. But I felt like for our first project, having an architect who had done this a number of times was really, really important because we really had to learn and ask a lot of questions. And it was great to have an architect who could speak with some confidence. And while there were some design changes that got made along the way, they had a pretty good shot at it the first time, which made it much easier. The Hillside project's a little different. There's a really exciting owner there who's building a large market rate passive house, net zero energy, 60 unit rental project. It might be one of the first of its kind in the country. It was very ambitious, but there's a little bit of a reinventing the wheel going on constantly out there as they're innovating and developing. And it's been in some ways more challenging because some of their ideas didn't work out and we were having to redesign things on the fly. If we did not have the experience of having already done the Waring School, we had a project manager and a superintendent and subs who had all been through the Waring School, and it helped us catch a lot of potential issues. And I think as someone who might be entering the passive house world again, having your first project be with people who've done it a couple of times may be really, really helpful. Because there is a lot of learning for architects and engineers too. And a lot of the details are not a natural growth from what they used to do a couple of years ago. This building also had the challenge that as a more traditional shaped building, some of the details around the windows and the roof line were a little harder to accommodate than at a more modern square shaped building like we did at the Waring School. So some of the key differences, and I'm going to go quickly through this because I think Aaron's spoken on this and you'll hear this a lot. To a certain extent, quality control, I think, is a big part of the difference. We know how to insulate buildings. We know how to get air tightness just under building code. It's a higher standard. And so your whole team needs to be thinking that way, that it's not necessarily all new, but it's a really high standard of practices that we already know. I will say on quality control too, I have learned through the two projects that we're doing that understanding and really focusing as a general contractor on the commissioning and the controls of those HVAC systems can matter because it's not just what we did 5 years ago. There is a level of complexity that is not always easy to understand. And we found that there was a lot learned at the end of the job with just making sure the owners understood what they had on their hands. The thermal, I think that's pretty obvious and will get touched on in any training you do, but clearly higher R values basically everywhere. And you just need to think through the implications of that. Windows and doors. The challenge that we found with windows and doors so far is there's a very limited set of suppliers. Depending on what your architect has defined as the standards, it can be a really limited set of suppliers. And a lot of companies that think they are passive house or are passive house don't necessarily fit the job you are about to bid on or build. And the process of dealing with the submittals and the back and forth around design with those often based in Europe window companies just takes a lot longer than when you're dealing with Marvin or Pella or whatever you've been doing on your prior projects. And I'll come back a little later, but hardware, particularly on doors, has been pretty problematic. And I think architects and owners and the marketplace aren't necessarily all in the same place on the requirements. So that's something to keep in mind. And then air sealing, it was interesting that I think our subs, the superintendents, the project managers, they get penetrations. They get windows and doors. We've already been talking about those as we build, but it seemed like where there was a lot of development of details is at the foundation to the wall connection and from the wall to the roof connection. And to a certain extent, it seems like architects had to learn that they need to detail those two connections. And sometimes we've been looking at projects where the architects had to be reminded that maybe they hadn't drawn those connections. They drew a nice wall assembly, they drew a nice floor assembly, and they didn't really tackle the question of how do you attach the two together. Opportunities for mistakes, learning by doing. We've struggled with almost all of these at some point just on these two projects. Lead times, it's a crazy world out there right now for lead times anyways, but particularly windows and doors, we really were finding that the lead times with some of these specialized products, instead of being 6 to 8 weeks, were 12 to 16 weeks. And the submittal process, instead of being 3 to 4 weeks, was 8 to 10 weeks. So all of a sudden, we're realizing that you have to think about your window submittals at the same time you're doing your rebar submittals. Like day one, you really should be submitting your windows and doors because things will come up and that process can take a long time. Assuming that you can do as equals, interchanging windows and doors happens all the time when you're bidding jobs and trying to be on budget. You can't make that assumption. And it really is important to test if you have an alternate vendor giving you the sales pitch about their window and how it's passive house. I would put that window in front of the architect and the rater and let them tell you if it really meets it. Because you can make some pretty big mistakes if you carry something that looks good and doesn't work. Then getting into more field issues, planning, and I think this is just a general rule that we all run into, but really taking the time to plan early and talk early to your subs. It's simple stuff, but simple stuff that's better communicated earlier. Caulking and sealing and taping around windows, I grossly underestimated on the first passive house that we did. The amount of, you can't just put a caulk gun in a guy's hand. You really need to look at caulking and sealing as a trade unto itself. We definitely went way through the budget we'd anticipated, but by doing so, we learned a lot for the next building. And it was more just figuring out what details are different than the old buildings. And then the last one is thinking the blower door test is easy is a big mistake that, our superintendents kind of said, oh, okay, you just seal everything up. And then at the end of the job, we'll do it. The subs think that, to a certain extent, the owner thought that. Our architect kept saying, be careful. And so I'll talk a little later about some specific things to do with the blower door test. Designers are learning as we go too. So I just want to point out that it's worth thinking about some mistakes that designers can make that are harder to undo later. And we've run into these just with a limited number of buildings that we've done. And it's taken a team approach to catch these things and fix them. Again, I talked about the windows a little bit and just making sure that the architect really is clear and has vetted the windows. They can't just write 4 window manufacturers in a spec and assume that all 4 are actually interchangeable. The biggest issue that we found in common on multiple buildings is that passive house doors don't necessarily play nicely with commercial hardware. And I think there are some solutions out there, but some architects are still, the solutions and the jobs aren't necessarily meeting. Panic hardware, automatic door operators for handicapped access, they can really struggle with the way that the locking hardware works on your passive house door that you would put on a single family home. And on the Waring School, they actually were able to design a system where they used a regular aluminum storefront system door in a passive house curtain wall and storefront system. But the door itself was just a regular Connier door that could work with all the regular hardware. On the job in Hillside, they've had a lot more trouble because they really had residential doors, but there are enough units, they needed commercial hardware for egress. So that's just something that's worth questioning as you're going through the estimating process on a project. The fresh air and design systems, we've had very different experiences. On one job, we had an engineer who'd done lots of systems and really just was able to plug and play. On the other project, the Hillside, they're still kind of redesigning and tweaking while we're roughing in. So those are just systems that, again, are worth questioning your designers on to make sure that they've really understood what they're trying to achieve, so that you're not just bidding on something that you'll find out later is not going to work. And then failure to draw conditions, the roof to wall and the wall to slab condition. On both projects, we've really had to ask some questions so that we can be very specific. It's not just a vapor barrier and then miraculously there's a zip wall and the two never touch, but somehow there's supposed to be an air seal. We really had to talk about how do you go from that vapor barrier to the outside of the zip wall, and what does it mean to get there? And we ended up doing sort of a belts and suspenders thing on some of these details, but it made us feel better so that we could pass our blower door test. Door and window conditions are similar in that you have so much insulation on the outside of the building that your door blocking, your window blocking, and the flashing around those are going to be different than what you've normally been encountering. And then I'll show you some details briefly on that as well. And then the exterior condition where your siding comes down and you have to get to the ground. For years, architects have been just living with kind of a thermal break there because they bring the concrete up a little bit above grade so that it meets code, and then your hardy plank or whatever starts above that. Now you bring up insulation and you have to find a way to cover that insulation that's on the outside of the foundation. It's a little different, at least in our experience, from what we've done before. Strategies for success. As we start a new job, we've been thinking a lot about this because we're starting a new one next week. One I actually got from the class I took down at Auburndale Builders is to take your plan set and take your pencil and draw the air barrier line on details around windows, at the foundation, at the roof to wall connection, because you'll often find that you can't draw it because you can't figure it out. And that comes to all those questions. We sort of designated a master of caulking and taping, that someone needed to walk around and just really think about everything that could go wrong. So again, we kind of blew it on the budget on one job, but all the money we spent on fixing that, we did early enough that it paid off in the end because we passed our blower door test. 3 and 4 kind of are the same thing. Ask a ton of questions of your designer, because either you will learn something that they may not have expressed clearly, or they will realize they don't know the answer. Either way, it's a good outcome as long as you're asking early enough. And then a big lesson that we learned on the first job, and even the architect who'd done this a bunch said this was something he's going to start recommending. Usually people have said you want to do 2 tests, one before your finishes and one after, one at the end. I was super paranoid about passing the blower door test. And so we actually did one before we'd insulated any walls, before we'd even received our doors and some of our windows. We temped in a ton of openings so that we could do a test just against the zip wall system and the connections at the foundation and the roof. And we didn't pass it, but we found a couple of really big leaks that would have been very hard to fix if we'd waited until those windows from Europe and those doors from Europe showed up. If we'd done the test then, I think we would have really been taking some things apart to go back and find the leaks. So saying how early could we do our first test, I think helps find 1 or 2 big issues that you would never have thought of and catch them while everything's really easy to get to. And then you do a second one once your whole envelope's closed in, but before you've drywalled. And by then, you're hopefully going to pass that test. And then when you do the third test, you're kind of like just making sure you didn't screw something up. At the wiring school, we passed our second test. And so the third one was nice because we felt like we had it kind of in the bag, and we caught a little issues around some final things that we had to fix. I'll be brief on these couple of details, but I just wanted to point out some of the things that we were mentioning. These are details from the wiring school. And this is the roof to wall connection on the left. One of the things they did there that was nice is in green, they had highlighted the connection. They drew the line for us. And that made it really easy to understand that their air barrier did not go up the wall and across the roof sheathing, which is one way of doing it. Their air barrier went up the wall, across the plate under the trusses, and then under the trusses. and it let them put an incredible amount of insulation up above in those trusses, which was blown cellulose and very inexpensive compared to building up a lot of insulation on the roof. But it was really helpful that they drew it this way. And in fact, our other project also put the air barrier under the trusses for different reasons, but it was really interesting. I was not expecting that. And then on the right is where we had done the same thing sort of internally. We took a cut of the building and in the blue had said, okay, this is the line of the air barrier. It's on the underside of the truss, then the outside of the zip. It goes under the overhang. Like we followed it all the way down. And then we actually had a tape detail that brought us all the way in down to our vapor barrier. At Hillside, this is the one in Newburyport, their detail did not actually correctly show a complete connection. They had a slab with vapor barrier under it. They had zip panel on the outside, but they hadn't actually drawn how you connect the two. What we ended up doing is wrapping the vapor barrier under the wall plate, and then we actually taped from the concrete over the vapor barrier and up onto the zip with one huge seam of tape that created a really, probably overkill, but a really bulletproof connection at that condition that helped tie those together. So what I drew in blue here, we'd actually added that element. Another thing we'd learned is that the flashing, a lot of the times these flashing details are drawn the way you would normally draw them. They go right behind the siding and then pop out over whatever it is you're flashing over. But we learned that what you really want to bring those flashings back to where your air and water barrier is, which in this case was the zip panel. And once we spoke with the architect, they pretty quickly said, oh yeah, you're right. You want your flashing to go to your water barrier, which was actually not right behind the sheathing or the finish. It was back against the sheathing. So the red line was what we revised it to. A new detail for us, this is about that foundation condition where often in the bad old days, you just had concrete that stuck up above the grade and then you picked up above there. At the Waring School, they'd actually designed this fairly robust, big custom metal flashing, and it looks awesome and it's pretty bomb-proof and it hides the fact that you have a lot of insulation coming up above grade. We've also seen it done with EIFS or with cement board that they parge, so it looks more like a stucco finish. But it's just a detail that didn't always get finished this way in our experience. At Hillside, similar to at Waring, same thing. This is the shape of the building, and you can see at the corners in blue, for our own use, we drew how that air barrier ties together at those corners. And in this case, because we were buried into the side of a hill, we actually had an interesting detail where we were connecting to the retaining wall midway up the building from the outside of the sheathing into this big retaining wall. And then the retaining wall concrete, which has waterproofing on the outside, really kind of is our air barrier there. And then we pick it up down at the bottom. This was another where we went under the trusses for the air barrier. And here it was because with a pitched roof, it's really hard to go up and go over the roof because you need a lot of thermal insulation outside of that air barrier or you get condensation issues. So if you run originally they had drawn it right under the metal roof and realized that wasn't going to work. And so they actually dropped it down under the trusses. So that was sort of a quick touch. I think I'm just trying to highlight sort of the strategies we use in approaching new jobs now. Like these are the first questions I ask when I get a set of plans to look at. And hopefully it's all going to turn out well in the end. So for the Waring School went great. Hillside's going really well. I think we have a lot of confidence to tackle the bigger projects, having learned a little bit on a couple of smaller ones as we went. That's it.
Excellent. Thank you so much. There's any quick questions, we can address those now, but we'll have time at the end for questions for everybody as well. So far, just a lot of thank yous in the comments, not any questions.
Thanks.
So yeah, so we'll get to some questions. I certainly have some for you, but we'll wait till after the next presentation. So Ed, I see you there. Hello. I'm going to turn things over to you. Ed's spoken at some of our events in the past and shared some great lessons learned. Very excited to have you back here for today's workshop. So take it away.
welcome and thank you, Aaron. Correct. We did a little bit of a presentation at the BSA recently, and gonna see if I can share my screen here and get to the presentation. Going to be focusing on so a lot of the same kind of principles, lessons learned, a lot of what Nat mentioned. We were very fortunate to come into the passive house world through an owner who is POA, multifamily, affordable market rate owner. Does a ton of affordable though, and they do it in multiple sectors of the country. So in the fall of 2018, they had an RFQ come out for the loop at Mattapan Station. And give you a little bit of background on that job. Is a little bit about myself. Chief Operating Officer for Delbrook Construction, JKS. We have an office in Quincy. We have an office in Falmouth. I graduated from Northeastern, and I have about 26 years in the industry. I was fortunate enough to help start Delbrook with Mike and his father back in 2004, 2005. So been there a little bit, but today we're going to focus on the POA project at Mattapan Station. Design team, as I mentioned, POA is the owner, joint venture with Noistra, who also is doing multiple jobs in and around the city. Civil engineer is Howard Stein and Hudson. The collaborative group is the landscape. On the architectural side, we had Mass Design Group, did the original kind of concept drawings, and then TAT took over doing the construction documents. O'Day Engineering, structural engineer. And then the next couple of guys are really, really important, to the previous presentation. People and teams that have already gone through Passive House is a tremendous asset to a GC as you're going through the estimating. Lessons learned for us is huge. So Peterson Engineering is the MEP engineer of record. And then Building Evolutions Corporation, Guy Ken, has been a tremendous help to us as the passive house consultant for POA in other areas of the country. So he was a great asset to the team, helped TAT a lot when we were designing and finalizing the plans. McPhail's the geotech, and then Clear Results is the sustainable consultant that will be doing the third-party verification for all the passive house. So getting into the loop at Mattapan Station, podium construction, everybody's probably very much familiar with. It's 5/1. There is one area of the building that has 2 levels, 135 units, rather large job to getting into passive house, 171,000 square feet, has 10,000 square feet of commercial on the first floor. The project is not going for passive house on the commercial side. They are just doing the passive house on the residential side, which I thought was an interesting take. And then 18-month construction schedule start to finish. A little bit of it, more of a disadvantage. We're probably only a quarter of the way through. We've done some post-tension work, and we started a couple floors of wood framing. So my presentation today will be more of a lessons learned through estimating up through pre-con and setting the job up for success. It's kind of that way. Kind of give everybody a brief timeline. Passive house going back to the fall again of 18, RFQ. We were selected by POA to be brought on for pre-construction. We actually did a passive house kind of conference downtown prior to COVID, and with the team, and then kind of got kicked off in February, March with the first pre-con and meetings with TAT. And then those first couple months kind of working on what I refer to as a control budget. And that's a really big piece of, when people talk a lot about price point and, a lot of affordable housing, most affordable housing projects now are trying to achieve passive house from an estimating perspective and a cost perspective. So as part of my presentation the last time on BSA, it's super critical that your baseline budget is a reasonable budget. It has, code, it has stretch code, it has the mechanical code, it has all the normal everyday stuff covered in, the basis of your control budget, because if not, your passive house, cost delta will be a little bit higher. But for this job, the baseline budget was high enough as I get through and go through the cost estimating, it was a key piece that our baseline budget, and because ultimately we landed on 1.5 to 2 points of cost, which was roughly 600,000 to 800,000 on a $50 million job. So if the baseline budget wasn't where it needed to be with respect to HVAC design and other things like that, I think the delta would have been different. And I think that's what a lot of the market rate builders are kind of suffering with now. I think their baseline pro formas are too low. Their design's too low. So they're, getting concerned that they're, and we see it, we do a lot of work for affordable and we do a lot of work for market rate owners, and they're a little bit more sticker shock on the market rate side than there's on the affordability side. So as April started on and we first got introduced, and then more importantly, the subs kind of got introduced to their first kind of take at design of passive house. And our budget went up. It went up $4.5 to $5 million. And at that point we had to have some meetings with POA and TAT and all the consultants, because we obviously their take is they weren't seeing that price delta in other areas of the country, and they wanted to kind of educate us. And it was super important that we did that. We had multiple meetings. We first had meetings with the HVAC and plumbers. We had meetings with the windows. We had meetings with the drywall guys. We had meetings with the framers. And the team actually helped us understand the materials, understand the manufacturers, understand, and get everybody's anxiousness down, get the subcontractors. The more they're confident in the products, the means and methods, their price point came down. And as we were proceeding into May and June, that number quickly went down to $1.5 million to $1 million. And then as we finalized documents into even August timeframe, we were at the $1.5 million. It went out to competitively bid again in October of 2019. We retained, and we were still the low bidder and most responsive bidder. And ultimately the project landed at that 1.5% to 2%. Ended up being, I think, 750,000. I forget right now because there's so many other moving parts and pieces when the budget was finalized. But we started out at 4.5 million, which obviously wasn't going to work. And through education from POA, TAT, got our subs comfortable with how to build the buildings, with the familiarity of all the details that the prior presentation went through. We were able to bring it in and ultimately start to build the job. And we started construction and in November. Had a little bit of delay with the MBTA, but that's kind of where we were there. Cost drivers that we kind of learned throughout the pre-con is the night system, which again, everybody's familiar with your typical GERT system that helps you support your exterior wall. It's, one of the slides previously showed kind of the Cascadia clips. That's also an option. We typically like to use the night wall system. It's a thermally broken support system for your GERTs. It does increase cost, but it's definitely an achievable system to help with the thermal bridging. Reducing that exterior wall insulation is obviously a decent cost driver. You're going to end up having, we ended up going with 2 inches and 3 inches at different locations of the mineral wool versus your fiberglass on the outside. And then I think we're up to a fully cavity of, I think, R23 blown in on the inside on the exterior wall. Aaron, and that also mentioned the continuous AVB, super critical. You got to get that air barrier up and over the roof. You got to build it and then put the parapet on afterwards. Windows, another big cost driver for us. There is, as previously mentioned, very limited at this point suppliers, manufacturers that are comfortable, that actually can achieve the values. We ended up going with Alpin windows on this project. POA had used them again in other areas of the country very successfully, but it definitely is a different price point. You're getting into the $55, $60 a square foot when you get into these windows versus your typical Pellers and all your other smaller guys that are going to be in your $35, $40 range with your fiberglass windows. So a little bit of a price point there, but I think it's coming down over time. The good thing about these windows, though, they come a lot with extension jambs, which is a kind of a cost savings versus having to block out or deal with the siding guy having to do difficult returns on these depths of these windows. The window suppliers are now getting better at having extruded trim pieces, which is helpful. A big piece for us, passive house and no passive house, I think, is the aero seal of your HVAC systems. Duct leakage testing is going to be a big deal. It's a big deal anyways in normal projects, but passive house, the requirements are even stricter and part of the overall success of the job. So we carry it on all projects in general, but absolutely is a must on passive house projects. Spray all your duct works to get your duct leakage to a certain point where to the Evie's point, you can't underestimate the blower door test. You can't underestimate, no matter how confident the ductwork supplier is or the subcontractor. You got to insist upon them hiring either an aerosol subcontractor or have him to be them. We have some HVAC contractors now are certified themselves. So Armor wall is an interesting one that I learned. That thermal bridging. Anytime you have a Juliet balcony, or you have a canopy, or you have anything that extrudes out that needs structural support outside of the sheathing, again, continuous air barrier, but you also need the structural component to attach to your building. And they're called structural blocks. It's minimal cost, but it's definitely another driver. Talked about making sure the units are all sealed tight with the blower door tests. And then there's a little bit of a premium on the plumbing side because the plumbing testing requirements for hot water are a little bit stricter than normal. That's some of the cost drivers. Unique challenges for us. Testing requirements, previously talked about. Multiple mock-ups, highly recommended. Blower door tests, we're gonna do them by floor, by wing, before the facade's put on. Everything that the previous presentation talked about is a big deal. Just making sure that's in your schedule, making sure your subcontractors know that you're going to need to do that as you go, not wait until half the building's done or the entire building's done. From a cost perspective, logistics, but also schedule. You got to keep that in your schedule. Duct leakage tests, as I previously talked about, heat rise on the plumbing. PT slab penetrations were a big deal for us here. The entire building is PT slab. Spent a lot of time focusing on that, how to do it right. Not only from a structural perspective, having to do penetrations after the fact is a big no-no on a PT slab, but also thinking with the commercial space below, making sure that the barrier from the residential piece to the commercial piece was super critical for us, learning those details, locations. And then another area, if you have internal kind of rooms like a trash chute room or first floor retail that has exterior openings, but they're interior to your building, you got to focus a lot on making sure that that room or that area is completely sealed. And then also, somebody I think mentioned having drawings in different colors. Our contract drawings had full. I think we have 8 to 10 drawings that show the air vapor barrier throughout the building, all color coded by floor, by plan, by section, is something that your architect needs to do. It allows the subcontractor to understand the scope, which keeps the cost within reason. So there's no guessing. And then ultimately, you can't afford to have any mistakes in the field. Lessons learned for us, the coordination of the night wall system was a big one with the windows and the framer. Cost associated with the VRF. Again, if your baseline budget has, the down and dirty Aquatherm system or a wall pack or all the other different versions of what market rate or hotel based or those HVAC systems on VRF, then you'll have to have a little bit of, cost there. What was interesting here, and I didn't note it here, but they dealt with the ERV system a little bit different on this job to limit the amount of penetrations in the outside walls. We went to a central-based ERV system, and they also put the ERVs on each floor. Not every job will be able to do that. You have to give up square footage on each floor to do kind of like little closets, but you also need to have access to the outside wall. So Peterson is a big fan of horizontal and central systems. So we ended up limiting a ton of exterior wall penetrations. The ERVs are all centralized. And then they have minimal amount of exterior penetrations, which will obviously help us out. And then, as the gentleman mentioned before, the panel shop drawings for us were huge on two sides. And then I think Aaron touched on it, trying to limit or increase the spacing to 24 inches. Some structural engineers get it's a challenge, but you just got to talk them through the process. And then also when the panel drawings come in, making sure they don't double, triple, quadruple the stud packing per se. And then our contract drawings also have all the sealant that we talked about previously. It has to be done. We have a separate contractor that's going to be responsible for that. And then from a GC perspective, we also added, we have a full-time field assistant superintendent who's going to be our passive house superintendent from start to finish. We're not going to break it up. He was part of the pre-construction. He's going to be part of all the mock-ups. He's going to be part of all the lessons learned. He has to go around and make sure all the sealant is done with not the drywall sub, not the insulation sub. We have a sealant sub on board, which I think is going to be a big benefit to us. So for me, in closing, it's just we learned a ton. Still under construction. We're only on the second floor of wood framing. We don't finish construction until May of 22. But we also, I think, we're going to start another 140 units in Brighton coming up with 2 Life at J.J. Carroll. I have another 140 units in Newton. It's every job. So that's what we're preaching to all our. I think we have 4 or 5 already certified builders. We have a couple designers as well. There's 2 different paths you can take. From that perspective, we wanted a couple of our estimators to go through that course. It's everybody's doing it. It's not going to be that big a price point once the manufacturers get caught up to speed. Once the subcontractors get caught up to speed and get comfortable with it. I always refer back to when, LEED was a big deal. Back in the day, everybody freaked out about LEED and LEED this and LEED that, and there was $1 gazillion dollars. And then come to find out now it's just common, typical practices with the new energy code, with all these towns, whether it's stretch code, the new energy code, as long as you get a VRF system with good controls, with a good control contractor is another thing. Not only AeroSeal for your HVAC contractor, but try to get your HVAC contractor to sub out their controls so they don't try to do it with, their typical ductwork guy is another big lesson learned for us. And then just that we're very fortunate that we were part of a team that has done it before. I think there was probably 30, 40 meetings throughout pre-con with the architect and everybody and us and the owner. And so when the CDs came out, they were pretty locked and loaded. It allowed us to do awesome scope sheets. So far in the construction, there's no I got you moments. Everybody is fully understood the scope, has asked all the questions in pre-con. I think it's good for TAT. It's good for POA. It's good for us. It's a great experience. It's been awesome for us. Estimating jobs now. We know the price points. We know the touch points. Our subs know it. They're familiar with all the products and manufacturing. So for us, it's what everybody's going to be doing. So, and we also finally, we do it in-house as well. We have a full learning and development, department. We've brought Clear Result in. We've brought, new oncology is going to be coming in. You got to take all these lessons learned and train the people that aren't necessarily on a passive house job, get them up to snuff, because you got to have certified passive house. Sorry about that. I think I was muted for a little bit.
Thank you, Ed. That was fantastic, and I really like your last point there. And I think you're exactly right. It's what it's what we're seeing in the construction industry for sure. Is this is becoming more and more mainstream. It's being incorporated into local zoning ordinances. Obviously, the state code is working on it in some capacity. So whether it's passive house certification or just these high performance details, every project is going to be incorporated in some way or another. Both of you. So I have questions for both of you. Everybody else, please type some questions in the chat room. Let us know what you want to talk about. But I do want to talk a little bit about training. You both touched on it a bit, a few different ways. So I wonder if you could talk a little bit more about, well, I'll start with Ed. You talked about how you kind of have this in-house training program now. Was this always the case? Well, let me actually ask it in a different way. When you first started doing passive house, how did you approach training your team? You have both this in-house program. You also mentioned receiving some training from the developer. How did you get your team to understand the passive house details?
I mean, most contractors are, we all have learning and development lessons learned and, through normal construction, but I quickly saw that passive house. So we ended up getting, 7 people. They took the course, the 3-day course, took the test, passed the test. So we have 7 certified builders and we have 2 design people with, I think, another 4 to 6 coming up shortly. But I didn't want to just wait for that course. I mean, at the end of the day, we wanted to lessons learned from your own staff, having a superintendent go through that course and then teach other superintendents, have a project manager go through the course, teach the other project managers. You don't necessarily need to wait for that person to go through. You can use that and also educate. I mean, we have a lot of subcontractors. We have a lot of people to train. So we do a lot of that internally on a weekly, monthly basis. Emily Sheedy heads up our learning and development department, and we help train there. It's just a typical. We bring HVAC consultants in, we bring electrical consultants in as our normal course of business. You just got to add on another layer and start talking about passive house. But don't lose the piece. You got to train your subcontractors on cost and materials and get them comfortable. So you take out the you get the uncertainty out of their number, and then you don't have an inflated number, because at the end of the day, DHCD has made it a priority. All the architects know it. Developers are going to get extra points for shovel-ready passive house projects. Again, I'm not the developer, but I'm hearing the rebates are there to support it. The payback is pretty good at a certain price point. But typically, DHCD has been leaning heavily on passive house shovel-ready projects.
Right. A very proactive approach. I mean, really training not just your own team, but working directly with the subs and everybody else that you work with to get them up to speed. Nat, you mentioned you went through the builder training as well, and you sent a couple people on your team through it later. I'm guessing you see value in that. You would recommend it for others. What approach do you take to training the rest of your team?
Yeah, it's interesting. I've been taking some notes with what Ed's doing as well. I mean, we're a lot smaller operation, but I do think that now that as we have new projects coming online, letting those superintendents who went through the first projects kind of help educate the rest of the team, like that sounds like an awesome way to help spread the language. And Ed's point was a good one too about lead, and I feel the same way about passive house, that I think that in a couple of years, there will have been enough projects that it will just start being sort of the new normal, right? I mean, to use the cliche, but that lead used to seem so crazy, and now it's like, it's just the way that everything gets specified and the code catches up. So I do think for the next couple of years, there's going to be a lot of people learning, but I think then you're going to have a pretty broad base of people who've, cut their teeth, and the architects and designers know, and it'll get easier, I think, as the years go on.
Question in here about change orders on the jobs. Well, how many? Were there many? But I'm also curious, like how that compares, say, for these passive house projects versus a non-passive house project. Are you seeing a difference?
I think you got to keep it consistent with your normal SOP. We use our normal SOP as lessons learned, and you add what we do, scope sheets and templates and pre-construction. It's a big piece with your subcontractors. So that this process that we went through at POA Mattapan has allowed us to, kind of get our template scope sheets up to snuff, and making sure and to get those guys to ask those questions up front, get those price points in. So at the end of the day, your change orders are minimal, because at the end, you just don't want to be doing coordination, or you can't say, hey, I didn't know that passive house detail. You have enough time. So in POA Mattapan to date, we've been pretty good. But again, in full disclosure, we're only up to the second floor, so I don't have the completed projects and the closeout of subcontractors and the T&M game and all that fun stuff that we all go through. So I can't speak to those lessons learned throughout the entire job.
I will say, that being involved in the pre-construction makes all the difference in the world. I think if someone came to me and said, here's a set of plans, you have 2 weeks, we're bidding you against 5 people, and then starting 2 weeks later, I'd be hesitant, because I think a lot of the conversations that happen during the pre-construction phase really do minimize the changes on any project, but particularly with a passive house. A lot of those details get worked out. And like Ed says, you get a plan set with everything marked up in color and everything's right. There aren't as many opportunities for confusion later on. So if you're getting involved in the pre-construction makes a massive difference, just like it does with anything with a unique project.
I want to talk a little bit about the quality control aspect. You both mentioned this, the importance of maintaining that on the job side, but you also both mentioned sort of these unique jobs that you're sort of assigning to members of your team, whether it's sort of the master of caulking and taping, as you said, or the people who are responsible for this. So I'm curious, in terms of quality control, how you're managing this with your team, but then also how are you translating this to subs so you don't have that level of direct control over? How are you maintaining that level of quality assurance?
Again, same as kind of the cost estimating, the same thing. We have a full QA QC program in general, with first inspections and typical. You just got to add to that, but you can't go in thinking that at least for us, we were nervous. The same as Nat was. that it's the unknown. You haven't built something yet. You need to have the oversight to make sure. So we assigned a cistern superintendent or a superintendent to own it from start to finish, be part of those meetings up front, all those design meetings. They were part of it. They're familiar with the drawings that came out. They're familiar on how to build it, so they can go out in the field and do inspections, because you can't wait till after the fact. You gotta address the QA QC on a weekly and monthly basis with your teams, and then educate your subcontractors. It's a great point. Not only from a learning and development are we teaching our internal team, we're also bringing in subcontractors as well, in exposing them to the lessons learned that we have to make sure they're going to be better subcontractors when they go to build the job.
I mean, we're a smaller operation, but I think one of the things that we did well on the first project was we were very fortunate to have a superintendent who was a really flexible thinker. I mean, they're all a lot of everyone has different strengths, and there are some supers who are and teams that are really sort of great at doing certain aspects of the job, but then there's some who are, I think, a little more flexible, a little more able to really recognize that something new is required. And I think that helped a lot. I don't think that you can throw just anyone into a new task like that. I think making sure that someone on the team, whether it's the super or the project manager, but someone's got to take responsibility for being as flexible and curious as possible to really figure out the new aspects.
And that's a great point. I mean, we had a superintendent who's on POA Mattapan. He's one of your typical builders. I do it my way. I've done it for 30 years, and it's going to be great. They're going to love it. You can't have that mentality. You got to be open. At the beginning, I'll be honest with you. I think TAT, if you ask TAT what they learned, was, I think, having a superintendent that's practical and knows how to put things together. Here's the detail we're trying to accomplish. These are the reasons why. And then the builder can kind of help formulate some details. And I think that the TAT did a lot. We were constantly changing details. And I think Nat had a couple slides where we were missing some details and adding details or flashings or connecting that slab detail to the wall detail. That was a huge piece. Luke Grady was our superintendent. He provided a lot of value to TAT to the envelope, because they know what we're trying to accomplish, but sometimes you need a practical builder to make sure you put it into reasonable logistical ways to get it done, so then he can convince the subcontractors to not blow it out of proportion. And yes, boys, we can do this, and this is how we're going to do it in a more practical way. I think it's a big.
Right. There was a question about the cost difference between HVAC systems. Ed, you were talking a little bit about estimating the cost for the VRF systems. If you could talk a little bit about what that cost difference looks like, and maybe to expand it a little bit, how you're approaching the difference with using, say, these type of passive house systems versus a traditional HVAC system.
Again, a lot of lessons learned for us in the beginning about VRF. We were pricing VRF, in healthcare jobs and assisted living jobs, and it's new to this area. I personally still question VRF up in this Northeast area. I know it's been very successful in warmer parts of the country. I think the manufacturers, at first, we have maybe one or two manufacturers in the area for VRF. But I think now we have multiple manufacturers. I think they've learned a lot about temperatures up here and adding, upgrading their systems to deal with, -20, -30. So I think the systems have got a lot better. We've had, just like windows, once you have more window manufacturers available, all of a sudden your price point will become more reasonable. So if you asked me that question a couple of years ago, I think the price point would have been $3,000, $4,000, $5,000 a unit more. Now, again, current code. I mean, we're doing market rate jobs now and more with VRF. It's going to be, everybody's going electric. Some of these towns like Newton, they don't want gas, they want electric. So you got a Brookline, they don't want gas, they want electric. So you're going to see non-affordable housing jobs also go VRF. It's not overly complicated. And your price point at the end of the day, it's probably almost going to be, don't hold it against me, but some jobs are almost going to be a wash, whether it's a VRF system, because your aquatherm systems are going to struggle on all these energy codes. So your baseline budget VRF, you're good to go. It wasn't that big a deal at the end of the day on POA Mattapan.
Great. The question here, just you guys were both mentioning LEED a little bit. Someone asked passive house and LEED, platinum advice or lessons learned. Maybe for you guys, what's the difference that you've seen on working LEED projects versus working on passive house projects?
I mean, for me personally, I think it's the scary part. You either pass or you fail. I think is the first thing you got to get over. It's super, at least the lead, if there's a little bit of flexibility, if you don't make one item, you don't get 8 points, you get 7 points, then you can go spend some money and get a green PowerPoint. And then you gotta land within a certain range. You need 50 to 65, or you need 55 to 75. And I think there's a lot of paper pushing on the lead piece, and you qualify, your site qualifies, or you're in a certain area where you have buses, and there's a whole bunch of other non-building components that allow you to achieve points on lead. A lot of good things on lead to energy performance and a lot of other things like that. But again, to me, that's like 3, 4, 5 years ago. That's like kind of way typical common practice now. I know new construction keeps coming out with different versions, but I think nobody really, if you have to build a lead job, I don't think anybody really thinks anything of it or anything. There's no price points more. I don't see people talking about price points with lead anymore. And then once passive house gets to a certain point where people get over the mock-up and they get over the duct testing and they get over the added insulation on the outside or the roof wall connections, and at least in my mind, I think you're going to see it all level out in a couple of years. That's my take on that.
We haven't actually done that many lead jobs. We did a ton of our little corner of the world. It was a lot of jobs that were designed to be lead certifiable, and owners who didn't really want to go through with the sort of the burdens that came with it. And so, and I think, which is from a design standpoint and a building standpoint, it's a good green building that incorporated the practices. But we actually really didn't have that many projects that had to go through the full process. So, I didn't find the passive house very complicated, though. I will say there's not a lot of paperwork associated with a passive house. It's just that make or break blower door test and screw it up.
And I mean, that's a big point too. If you go the certifiable route, certified route on the lead, you're spending hundreds of thousands of dollars in paperwork and, material calculators, and you're spending resources in the office, out of the office, trying to get to a certain number to get a plaque. I think some people thought that was a marketability thing. They were trying to, obviously do well with the energy, but also I think it became a marketing tool more and more. But I think that's kind of in the past a little bit. And passive house will maybe go through that same thing. But that's kind of.
Yeah, you both mentioned kind of one of the key points of passive house is those metrics. It's performance based. You have to hit these details to get it right. And it makes those details so important. I've heard this from other builders as well, that, it's about doing it right matters, doing the details matter. It's not that these concepts are completely different type of building. You're just doing it, but you're doing it really well. And the phrase I've heard is craft matters. And I think I've seen a lot of builders really respond to that really well. And I'm curious if you've seen this from your team as well. If you've kind of been, sending through these trainings, telling them about these new buildings you're working on. Are you seeing some type of excitement from them for working on passive house projects? Are they excited about the detailing, or do they see it as like, oh no, now I have to, now somebody's actually paying attention to what I'm doing?
Happily marching to the fields. Not always. It's always, every job's unique for these subs. So I think if you have good subs, they get excited because they recognize it as a higher level of quality. I think some do really see it that way. It's just, this is the next step in them feeling like they're at the forefront of their industry. And some guys, you had to drag them a little bit more into the 21st century.
I very much agree. If we can get Luke Grady to turn it around and be a believer, I think he's going to ultimately take a lot of pride in putting this one together. I think is the exciting part for him. I think having some people go through the test, it's no joke. The test, it's a lot of work. It's not that easy of a test. It's a lot of homework you need to do. You can't just be a builder for 30 years and think you're going to pass, the test. So I think that's a good thing for those guys. I think they were super excited that they passed the test, and I think they're going to pass that on. And I've already seen that happen internally, where the next group has gone on to schedule, the next test. They've been forewarned and kind of encouraged to don't underestimate the work you got to put into it. And that's a good thing. You're making builders better builders, and ultimately that's the goal, I think, of it.
That's great. For those listening, the test being referred to is for the THEIS Certified Builders Program. And I mentioned at the beginning, but that's been shifted online because of the situation we've been in, which makes it very flexible for folks to take. It used to be 3 or 4 days in a classroom, and now you can actually do it online. It's a little bit more flexible. So it's a good time to send folks through it while that flexibility is still there before it may become in person only again in the future. In addition to getting a 50% reimbursement for it. if anybody else has some questions, please, again, type them in the chat room. But until then, I do have a kind of a broad question for both of you. But if for all the folks out there watching who have never worked on a Pass Fail project, kind of what would be like the big takeaway that you would want them to know going into the first Pass Fail project?
It all comes together if your documents are right. You spend the time, make sure your documents are right. Don't rush into it. To Nat's point, if you have a developer come to you or a team come to you and say, "Here's my set of documents, go bid it," and then in 3 weeks go start building it, you're going to make a ton of mistakes. Again, we were fortunate that the MBTA caused a little bit of scheduling issues, so our pre-con period got extended a little bit more than we would have liked. But those meetings are invaluable. Making those documents airtight so your price point is consistent. Your contingencies can be used, but contingencies, unforeseen stuff, not trying to build a building that everybody wanted to build. For me, having those CDs really be CDs are a big takeaway that I would encourage everybody to push their engineers, their people, their internal teams, their estimators to don't be shy. Raise your hand if you don't understand a detail. Just ask the question. Let's get the detail in the drawing so we can educate the subs, push the subs, and be like, subs, ask the questions. What don't you see? What do you need help with? Because ultimately, going into it, we want to make sure your price is firm and we don't come back after that would be my big takeaway.
Yeah, I think having approaching it with a real fresh eye and some flexibility is also it's a requirement, but it's also sort of fun. I feel like it does, as Ed was sort of saying about the superintendents, it kind of reinvigorates you learning something new. And it does seem to, at least at this stage, because I think architects and engineers are also learning, or it's at least new for them. There's a nice team approach that it's not always like that on jobs. But I think knowing that we're all trying to achieve something that's a little bit different and a little out of the norm is sort of created a pretty nice team approach on a couple of these projects.
Great point.
Well, I actually don't see any more questions in here. Folks, this is your opportunity. If you have any for them, please ask them. Or else we might be wrapping up a little early today. But Ed, Nat, thank you so much for putting together your presentations today, taking time away to have a part of this. It's, I think, been a very valuable session. We're going to make this available as a recording so other folks can watch it and learn and get excited about working on these projects. Just as you both hinted at, I mean, this is something that's exciting and it's going to be the way we build. So start now.
Thanks. I appreciate the opportunity to meet everybody and first the opportunity and give everybody an opportunity to see Poa Mattapan. It's an exciting job. I think it's a big step for Passive House that we can get into the larger, get away from the single family stigmatism of Passive House and get into the larger multifamily world. So I appreciate everybody's time, and I'll share the presentation with you. I had updated the presentation a little bit. I'll send you back the PDF so you can share it with the group.
Yeah, thanks for having us, Aaron. It was really nice.
Well, thank you everyone for being here. Take care, and we'll see you out there. And to wrap up with some educational resources that are out there for you, starting with certification courses. So I mentioned both the Certified Passive House Trade Person course and the Certified Passive House Builder courses. These are both available online currently. The links are there. The Trade Person course is currently on demand, so you can take it when you like. The Builder course is online, but is held with some live sessions. The next one is starting August 3rd. You can register through these links or just see more information about them. There is that 50% reimbursement through Mass Save. You can see information in the application for that down there. Highly recommend these courses, especially now that they're online with the flexibility offered to be able to take them when you can. And with that reimbursement, it's definitely a good time to take these courses. Some additional resources. So there our own Passive House Massachusetts video library, which has a lot of recorded sessions, case studies, lessons learned, lots of different types of presentations available there. I'll highlight just one of them for you today, the Passive House Construction Workshop. This was a 4-part series, 12 hours of content in total, deep dives into construction methods for Passive House buildings, a lot of really great content there. The link to the first session is right there on screen, so definitely check that out when you have the time. A couple other additional resources. There's the BS and Beer Show, BS for Building Science. This is a weekly online session, kind of a very, informal get together, but definitely cover some good topics. Take part in that if you haven't already. And lastly, the Passfast Accelerator, which puts on a lot of great content. But I want to mention their Construction Tech Tuesday sessions, which are really geared towards builders, contractors, tradespeople. So check those out if you can, happening every Tuesday. But thank you so much for taking part today. That's our website below, and hope to see you in the future. Thank you.